Welcome, students. Today we're going to explore an important concept in physics: scalars and vectors. These terms refer to how we describe quantities and understand their physical properties. Let's start with scalars. Scalar quantities are those that have only magnitude, which means they are described solely by a numerical value and a unit. Examples of scalar quantities include distance, speed, mass, temperature, and time. When we measure or calculate scalar quantities, we focus on their numerical value and the unit of measurement. We don't need to consider direction because scalars do not have a specific direction associated with them. On the other hand, vectors are quantities that have both magnitude and direction. Vectors require not only a numerical value and a unit, but also an indication of the direction in which the quantity is acting. Examples of vector quantities include displacement, velocity, acceleration, force, and momentum. When we represent vectors, we use arrows to show the direction and length to represent the magnitude. The direction of a vector provides important information about its effect and how it acts in a given situation. To visualize the distinction between scalars and vectors, let's consider distance and displacement. Distance is a scalar quantity that tells us the length of the path traveled without considering the direction. For example, if you travel 10 kilometers from point A to point B, the distance is simply 10 kilometers, regardless of the path taken. Displacement, on the other hand, is a vector quantity that considers both the magnitude and direction of the change in position. It tells us the straight-line distance and the direction from the starting point to the ending point. So, if you walk 10 kilometers north from point A to point B, the displacement is 10 kilometers north. It's important to note that vectors follow certain rules when it comes to addition, subtraction, and multiplication. Vector addition involves combining vectors by aligning their tails and connecting the heads. The resulting vector, known as the resultant, represents the sum or the net effect of the individual vectors. Vector subtraction is similar, but it involves reversing the direction of the vector being subtracted. In physics, we often use vector diagrams, such as force diagrams or velocity diagrams, to represent the vectors involved in a particular situation. These diagrams help us visualize and analyze the forces or velocities acting on an object, allowing us to understand their combined effects. Understanding the distinction between scalars and vectors is crucial in physics because it affects how we interpret and analyze physical phenomena.